Hello, this is Mrs. Kimmel, and I'm going to work on lesson 1.1.3 for Algebra 2. So in problem 1-26, it's asking you if it is possible to input a -16 into function f of x. So if I were to ask to do f of -16, that would ask me to try to do the square root of -16. Can you square root a negative? No. So is there a problem? Yes, there is a problem. You can't square root a negative number. For now, telling you second semester, that'll come back up. Okay, the next question. This question, if you need to read it, pause. Come back. And in this question, it's asking you to describe the domain in words. What are all the numbers that can be used as inputs for the function f of x? So we can input any number that is a positive value. So the domain of function f of x is x is to be less than or equal to, and then the smallest value is 0, because I can square root 0. The square root of 0 is 0. And then it goes to positive infinity because we have the ability to square root of 0 and any positive value. We will get decimals and crazy answers, but it is possible to take the square root of any positive number and 0. All right, if you need to read, pause. Right. Sonia, in her logic, the final output is to be 11, and she thinks that coming out of function g of x, it should be always a negative. So take a look at the function g of x. When you have a negative in front of any number squared, when you square a number, this part will always be a positive value. But then when you bring down that negative, a negative on a positive number makes always a negative value. So does it make sense that Sonia's logic? Yep, Sonia's correct. Why? Because that negative hanging in front of always a positive number will make the output be always negative. Okay, next question. Again, pause if you need to. Come back. All right, it's asking you to describe, and so we don't have to be detailed with notation, but describe the range of the functions of g of x. So take a look at g of x, and like we said, there's only going to be negative numbers coming out of there. So if we're talking about the range of g of x, if it's always going to come out with a negative number, but what about 0? Because 0 is that unique number. If I squared 0 and attached a negative or the opposite of 0, that's still 0. So we're going to include 0 and negative numbers. So the range, if you want to describe it in words, is, we're just writing in words and describing today. We're not using proper notation. I mean, we always can, but that's not the goal of the lesson. Okay, use your graphing calculator to help you draw a complete graph. This is where you need to use the computer to type here into the function. So you need to copy that equation into decimals. So y. So do you see how my screen doesn't show me the entire shape? So we need to know a window that would show us more of the shape. Oh boy. So, you know, the other option we can do, we can zoom out just to get more on the screen. And that looks like an okay view. If you draw a complete graph, I would find some exact lattice points in the function using the gear and changing the function into a table of values. There's 5 great points. But on a parabola, it would be really nice to have that critical, very important point, which is the vertex. So let's see if we can find it when we just extend out the table. There, I think it is. Look at the symmetry in the table. Negative 24s match around negative 25s. Negative 21 matches around negative 21. That's because this graph is symmetrical. A parabola can be cut right down the middle. So where is the vertex found? Right in the middle. And that's a very critical point. So if you were to complete a complete graph, I would include that point, and I would include the 2 others that match around it. So graph those points, connect them, you should have a pretty good graph. So use your graph and describe it completely. Okay, so use the graph. What window settings allow you to see this complete graph? If you hit the wrench here, you will be able to see some decimals and approximations. And what you should notice is that along the x-axis, what we're looking at, maybe be kind of large. We don't need to see that much. So how much do we really need to see for x? Maybe from like -5 to +15. That'd be good. For y, I would choose about -30 because something below 25, just so I see the vertex on the graph. And then I'd go up to +5. So what window? X is going to go from -5 to 15, and y will go from -30 to +5. So x that'll be a great window. So if you go back in Desmos and type that here, you will see exactly what I'm talking about, which is a great window to see that whole shape of the graph. Okay, so then use the graph. How are the settings related? Like I just talked about before, how are the settings related to the domain and range? They should pretty closely match, except for with these infinities. So domain, for a parabola, how far left and right does it go? On forever. So what settings relate? It's how much you have showing on the x-axis. So again, going back into Desmos just to show you what it looked like. Oops, sorry, clicked too many times. So right here, what x-axis? And ironically, it's written in compound inequality, which is exactly what we need to write the domain and range. So Desmos was really kind of very awesome. So how are the settings related? See on my screen should show me all my critical points, x and y intercepts, the vertex. Okay, problem 1-29. Sketch a function that has a domain of all real numbers between and including -3 and 10, so from -3 to 10 for x, and for y from -4 to 6. You do not have to write the equation for your function, just verify your endpoints with your team. All right, so if we're looking at from -3 on my graph, if x is supposed to go from -3, here's what I'm thinking to do. I'm going to put in some dash marks when x is -3. So this is my left bound because I can't go past this. I can't have any values any smaller than -3. They have to be bigger than -3. And then they can go all the way to +10. So I'm going to put this little dash line, as much as I can make dashes, along the x-axis of where it can go. What I'm trying to do is box myself in to get exactly where my graph of some sort should be. All right, and then if y is supposed to range from -4, so here's where y is -4. I'm just going to draw on a horizontal line there. And it can go to +6. So just going up here and making my little dashes. And the method to my madness here is that this box limits where your function should be. So if I'm going to draw a function, I can make a straight line from here to here. Now that's not a straight line, so be careful with that. It can actually hit and supposed to hit this point and this point because they're saying it could be equal to -3, it could be equal to 10, it could be equal to -4, it could be -6. So we really should extend this line out to actually hit those points. But do we go past or outside of that box? No. So did I make a little bit of a boo-boo here? Yes, right here. You don't want that to go outside of the box. So we can have a line segment, a segment with endpoints, but we cannot have a line that goes on forever. Can a graphing calculator help you find the solution to a system like that? So if we have 5x minus y equals 35, and we have 3x plus y equals -3, first graph the system in a standard window, try to find the solution. So let's make sure we have, then it's asking you if you have time to solve it algebraically and just confirm your answer. You should notice that the two methods give you the same solution. Let's move to the next window because this is where you've typed in Desmos. They've done it for you. You don't have to type it in. And I can scroll and look for the point of intersection. This is where you might have to adjust the window in your graphing calculator. But it looks like this is the point of intersection. So right there, my solution is 4, -15. How nice was that? Love Desmos. It graphed both lines for me, and it gave me the point of intersection. I just had to find it. So with your graphing calculator, you change the window to see what you need to see. I need to see this point. A solution to the point of intersection of two lines is seeing that point of intersection on the screen. So the solution to this question is the point of intersection 4, -15. So graphs and graphing calculators are very nice and friendly. They're user-friendly. They help us maybe on the ACT. They're not always used on our tests. So FYI on that. And that's it. Have a great day.